All right, guys. So, so in today's session, we'll be going through the uh, mapping data flows. So we at high level we touched upon what are the mapping data flows and uh, what are the different scenarios that you need to create a mapping data flow. And today we will deep dive into each of those actions and how they work. What are the different pros and cons when we choose those options, and also uh, we also discussed about the infer schema, right? So if when you go to, for example, so I can go here and I can create a mapping data flow. What is this weird behavior? Okay, now as we did, let's say we need to add a source, right? So let's say this called as an employee source. Okay. Now yesterday I have asked you to do some exploration on what is drift schema and inferred drifted column options, right? So what is a drift schema? Have you guys come across this word in your day-to-day work, or have you read anywhere?
No, I'm not aware of drift schema.
Yeah. So let me give you an example. So this is my employee data set, right? So this is, for example, in my case, I from the source I'm getting employee ID, name, salary, and department number. Okay, and that's how I been programmed my pipeline to take it up and use that. Okay, so now what if happens? Let's say tomorrow when I'm fetching again, so I got a new column saying country, right? So this is called a schema drift. So that means the schema is not confirmed or not static enough to get the only this column. There may be changes can happen. For example, they may have a new column they may added, and they may add another colon, or they might have removed department number and just have only uh, employee name, ID, name, and salary. So these kind of things can happen in the real time, right? Based on the upstream system can make some changes to the data feed that they're sending on daily. So irrespective of those changes, so drift schema in the sense, so if the upstream system is making these kind of changes, then also the pipeline has to process those data and get the data to our target. It should not fail. It should not leave those additional data what we are getting from upstream system, but it can adjust to those changes, and it can it can infer and create those data types and then bring to our target. So that is what is called a allow schema drift. If you not allowed schema drift and any changes happens, let's say there is an additional column being coming over here, so you will be your data factory will not pick this column, or it will give you just an error saying that we have a data type inconsistency. Okay, so this is the situation that can happen, and that is why the ADF gives you an optional whether you are allowing schema drift or not. And when you allow in schema drift, what are the infer drift column types? right? For example, let's say country I'm
Sir,
getting.
question. Sorry, interrupt you. So this portion allow schema drift must be enabled all the time, or some scenario it shouldn't be.
Yeah, it shouldn't be. Let me complete this, Sachin. Okay.
Okay, thank you.
Yeah. So once you allow the schema drift, what would be the drift column types? That because because data flow doesn't know what are the data types, or data type can come and as a new column, right? For example, we are adding this as a new country, and tomorrow if you have another column as a bonus, right? And normally in what happens, we are using a CSV data. In CSV data, all the columns by default is a character type, right? It doesn't care whether it's a department or salary or bonus. It by default, all the columns going to be a string, character string. Okay. So in that case, if the source system, what are the data type they're sending, just use those data types. That means as is, whatever this is, whether it's a string or numeric, bring those data types into our system as well. Okay, so these two go hand in hand. Okay, now to answer your question, Sachit, let's say I don't want to deal with whatever the additional information they're sending. For example, country bonus. I don't want to deal with all these things. I'm only conformed to my only schema, which is employee ID, name, salary, department. In that case, you can just use a validate schema. So
Okay,
validate schema in the sense, it just takes you whatever the schema you it's validated and just takes this one. All these additional columns will leave as is. You will not get that additional data.
okay,
Okay.
okay,
So that's the difference. That's why see, these are the options. ADF is good. Nothing is mandatory. It's all depending on your situation and your scenario, and then accordingly you will choose the options. Okay. Now let's see how this works in real time. Okay. So the data set, I already created a data set. Let me use that. Okay. You can see the data. Right. We have employee ID, name, salary, and department number, which is good. Okay. So now let me add you allow drift schema and infer drift columns. Okay. Now let me change it over here. Maybe I can add a bonus, which is 10% of salary. Okay. Uh, okay. Now go to okay. So I already have employee data. Let's upload a new file, the modified one. Okay. So before I update, I just want to talk about the some of the options we already have. So now, if you see source options, you have there are so many options available. For example, you can use the partition and number of files you can restrict, and list of the files. So all these to read multiple together, maximum columns. So all these options we can look into it. Okay. So now once you do that, you see my automatically it gives you um, the projection, right? What the projection data look like. So we have employee ID, name, salary, department number, and as you can see by default, all are become a string, because when you're dealing with the CSV files, all the columns comes with as a string. Okay. So now in this case, what we can do is, if you can change this the default format. Okay, so let's say if it's a whole number is coming, I wanted to take it as integer. The whole number in sense, for example, 1000, 2000, 5000. These are the whole numbers, right? So those numbers take it as an integer. Okay, don't just keep it as a string. Okay, so I defined my schema. Okay, so now let see the reset schema. Okay, we'll come back. It takes some time. Okay, so now we also have an optimization techniques. It gives you, for example, partitioning. Have you guys heard of partitioning?
Yes.
Right, so it's a very another concept when you're dealing with data. So partitioning is basically splitting the data into multiple chunks to process speed up the process. Right, for example, you are you're dealing with a million records, right? Either you either you process 100,000 records, which is a 1 lakh records 10 times, or you process a whole 1 million records at a time. It's depending on the process, depending on the compute, depending on the storage you are using. Accordingly, you can create multiple partitions and easily process those partitions in a concurrently. All right. So now when you do that, what you can also inspect. It gives you an option to inspect the columns and the data types when you do before moving to the final data preview. Now data previews, as you can see, it will also provide you to preview the data from the source. Right now, here is the catchy. See, we can also look at the data at from the data set. We can preview the data, but this data preview gives you an opportunity after you have the all the transformations, and it's finally how the after applying those transformation, how the data is going to look like. It will execute you in a debug mode. Okay, you can see data flow debug here, right? So you need to turn on this debug. So when you turn on this one, it asks you the integration runtime. Okay, so we already selected integration runtime, basic auto, auto resolve. That means with the Azure, the default Azure managed compute power we are using, so that it creates a cluster. You can see the cluster. So it's basically creates the cluster and deploys the cluster and executes the debug, executes the transformations in the debug mode, and it gives you preview the data option. Clear? You can see. Okay, so these options are very important for you to remember. See, you see, executed the code from the source, and it gives. Of course, we haven't had any transformations. It just give us as it is, like employee ID, name, salary, and department number. Okay, but in real time, if you have so many transformations, and then finally, before moving to destination, you want to visualize the data, you can go to data preview and you can visualize the data after the transformation, how it look like. Okay, and it basically it can only happen. You need to turn on the data flow debug, and which when you turn on this one, automatically Azure provides you a cluster, creates a cluster, and executes those transformations into cluster and brings the data over here. Okay, so it's very important to you understand all these options before we move to further. Okay, so now you can see there is an import projection. We can change the uh, data type. Let's change the data type. You see now employee ID, which is, see, we have given make it, if it's a whole number, make it an integer, right? Salary was a whole number and department was a whole number. So by default they become a employee ID also whole number. So all three columns have become a integers. Okay, so that means the default schema what we are getting from CSV are all our strings. Now we have converted the whole numbers to integers. Similarly, you can set up, for example, if you're getting a date format, right? It's all available different date formats, and you can, if you want to use those date formats and as well as time formats, you can see, and you can convert them into time or fractions, right? So fractions, if you're getting, and you can either based on your target schema, based on your target, where do you want to put that code, and you can choose those either double, float, decimal, something like, right? Boolean values. Sometimes, if a value true or false comes from the source, right? If it's a true, you want to take it as a zero. If it's a false, you want to take it as a one, right? Or the other way, right? It's depending on the use case and depending on the scenario, and according to that you can set those values. So if you're getting a true or false from source, you can convert them into zero or one. I think Sachin, you asked that question, right, sometime back.
Yeah, I have one more question, sir. So in real life, we just don't have integer. So like we have big int, other data types, right? In that case, how it is going to handle that part? Like, so suppose I exported a data which is more than integer range, means it is a very big file, maybe probably a CSV or some other file which can it support, right?
Yeah.
In that case, the data type must be not integer, big int. So how that part we are going to handle? Because my only worry is ADF means we are going to deal with a huge data warehouse related stuff. So in that case, how we are going to handle?
Yeah, so you can see integer, short is there, long is there. You
Okay,
can use any of them you can customize. For example, long is most comfortable for the big int kind of a thing, right?
okay.
Integer is the general. Okay, or if you're not able to decide, just use none. Don't use that. Just use as is, whatever the source system is sending.
Mm-hmm, mm-hmm.
Right. So you
Okay,
can use all these things.
okay, okay.
Okay. So now you see all the whole numbers have become integers. Okay.
Mm-hmm,
So this
mm-hmm.
is this is going to be our schema. All right. So now let's say I wanted to, sorry. So I have given allow drift schema, and I have added bonus, right? So let's see how this behaves. So now close this. Okay, so just now we have changed it and we have added. Now go back here. And see, refresh our scheme. You see, the bonus been getting automatically. Though it's not there in the production projection and all, there is no mapping available. But automatically, since the allow drift schema we have selected, so it's automatically taken the bonus also. And then we also given in our options we have given the if it's a whole number converted to integer, right? So since it's a whole number, you can see the data type is 123. So the data type is 123 means it's an integer, and is for string and character you can see ABC. So these are the indications you can see when you have a um, data types. If you want to know what is the data type of this, what is the data type this, you can use this 123 ABC indicators to tell whether it's an integer or it's a string. You can decide over that. Now, since we allowed the drift and we allowed the infer schema, so automatically the bonus again added. Now let's see what would happen. Let's remove this. Okay, and I think we need to upload it again. Now add one more colon, maybe country. Okay, now go back, upload again. Okay, so now go back and see. You see, so we haven't created we haven't checked the allowed drift and infer schema. Hence the newly added columns, which is bonus and country, is not picked up by the process. Only the schema which is confirmed by the data set. Only those columns only it's using. So the additional information, whatever you're getting from upstream system, we are just ignoring, which is okay. In some cases, we don't want to deal with all the data that they are sending, right? But if they're sending additional information that you want to capture, you want to be flexible, okay, use those options. Okay, so that's for the importance of having this one. Okay, so now add on more source, and this I would call as a department, and I will select the department data set. You can see the data. So on the department, I have two things: department number and department name, which is simple. Okay. So now go back. Just to preview the data. Okay. So I have a department number and a name. Now go to projection and define the schema. If it's a whole number, make it integer. So since department number is a whole, so we wanted to, since we have converted in employee data set, and here also we wanted to do that. Okay. We see department being changed to integer now. You can also give the other options if you even within, like say you want to append a dollar, right? You can use these options. If the dollar has to appear before that amount, you can use this. Or you can use, if you want a percentage, or you want to use comma separate, US format, right? Dollar with comma separate, all these options you can use. 00 is what Indian format, right? So all the stuff you can specify as well. Now, okay, so now we have both the things, right? Okay, so now we have two data sets. One is employee and another one is department. Now, if you see the first option, when you click on this plus sign, you will see a lot of the transformations that we can do. Okay, so let's join these two. Simple. If you click on join, automatically the join comes over here, and you can see this is, you can name. So since the employee department join, now if you can see my screen, so you need to specify this type of join. So if you're familiar with uh, SQL, so by default SQL gives you four types of joins: full outer join, inner join, left outer join, and right outer join. So full outer join in the sense all the records from both the tables. In the inner means only the matched record based on the join condition. For example, in our case, we are joining with the department number. So the only records which are matching with the department number only will come over here, come over in your output. Okay. So left outer. So all the records from the left table, you can see left and right, right? All the records from the left stream, which are matching with the right stream. Along with that, all the non-matched records from left stream also you will get it. Similarly, right outer join, all the records from the left, no, the matched records from the left, which is matching with the right, and along with the additional records from the right also you will get it. Okay. So now if still if the requirement is not conforming to all these four types, you can also custom, you can create your own custom cross product. So cross product in the sense all the combination of records from the both the systems. For example, you have a 10 records over here and you have a 10 records over there, then it's 10 into 10, you will get 100 records, which is called a cross product. Okay, so in this case, we want to use the join between employee and department. So the left stream employee already selected, and just select the right stream, which is department. So now once you have the left and right, you give the join condition, which on what basis you want to join condition, right? So you can give those, for example, you can use department number, which is equal to a department number over here. And if you have join more than one condition, you can add keep adding by keep pressing plus, and you can add more columns as well. Okay, so far so good. Now you can see when you select left and right, automatically the UI had created a diagram. You can see it's the employee data and as well as department joins over here. Okay, now let's see the options over here. So you can again the partitions you can select, but since we can use the same current partitioning, which is by default one, and you can see how the data look like. Right, so is the data being combined between these uh, tables? See, this is coming from employee and these two are coming from department, and you can preview the data as well. Right, now once the join happens, so what are you going to try it to? So we wanted to put this data into a output folder, right? So once the join, for example, I want to join, I want employee ID name, salary and department name. I want the department name from the department dataset. I don't want to 1020, right? So that's going to be our target. So what we can do is similarly copy activity. Here also we have a sync. So sync is the what the destination. Okay, so once you have selected employee data set and two data sets, you have joined two data sets, and once the after joining the transformed results you are putting into a sync data set, right? So sync is either it could be a SQL database or again another blob storage. Sync. So we already familiar with the copy, right? In copy also you need to provide source and sync, right? So similar concept over here as well. You have to select the sync and you can give the sync. For example, in our case it's a output sync type, again data set, we and you need to select the data set. So let's use a mm, okay, let's create a new one. Okay, so DS output, and you can use the link service. Okay, so output we can use it. Okay. Now if you in the output, let's say you are dealing with a million records, right? If you want to skip any line count, you can mention those line count. For example, after every 100 records you want a skip, right? You need a space in between, so you can you mention that as well here. Otherwise it's just all the million records is going to be in one kind of a without any breakages. It will just output to the one stream. So if you want to every 100 or every 1000 you want to have a break kind of a, you can skip those line count. Okay, now you can see the settings. So file name option, the default one, right? Or if you want to have your own, you can mention the what would be the output file name. So in my case I wanted to employee department output dot csv, right? So this is what the output name I wanted in my output. Now errors, you can see if there are any errors, and if you want to create log those errors into a storage, you can do it that as well. Okay, so now my mapping, let's see the output. Right? So it's auto mapping. So you can see one mapping, two columns in the input left unmapped. Okay, so we will see that. So if in case of any manual mapping, you can add mappings over here. Again, optimization, partitioning, and you can see how the data look like. Okay, and let's preview that. Okay, so this is how the data looks like. Now we wanted to add a department name, right? We don't want department ID. Now go to output and go to mapping. You you can see here, right? And you can mention the output column also if you want. For example, you want output column as employee number and employee name, employee salary. You can modify here as well. Okay, so we don't want these two columns, and I'm just so we want employee ID name and the department. This is what the output we wanted, right? So now let's go back, preview and refresh it.
టీవీలో 1 అవర్ ఉందిగా బస్ 1 అవర్ ఒక వీడియో కొట్టేస్తాం.
Guys, can you go on mute, please? See? And now I can map it to. So similarly, output format, if you want to change anything, date, time, Boolean values, you can give those values as well. So since we do not have anything, and let's do a and preview the data. See the output. We wanted employee ID, name, salary, and department name based on the condition, which is we given join based on the department name. So wherever the records are matched, you can see the output over here. Okay, since in this case, all of them are matching, so we got a total of 10. But there may be situation where you will not have all the matching, so you can using this header information, you can know came to know, for example, how many inserted, how many updated, how many deleted, all the numbers will come. So it will give you a glimpse of your transformations. Okay, so now let's go back our sync and see whether we have that file generated or not. Okay, we haven't run this, right? Sorry. So when you run now, publish this. Okay.
I think it was on output, right? Output.
Yeah, yeah. Output only I made. Since we are given single file name, right?
Yeah.
So it's giving. We need to select single. Otherwise, it will create many files which we don't want, right?
Mm-hmm.
So this partition basically helps you to um, to performance oriented, right? If you want to fix the performance issues, you can partition and do accordingly. Okay. So we have created data flow 1, and we can see that over here. This is the data flow 1. Now, how this is going to be executed? So far, we haven't executed, right? We are just creating the data flow, and we are just we're previewing the data, right? That doesn't mean that we have executed. Now,
Mm-hmm.
how do we execute this one? You can see it up, create a pipeline. Okay, so now call
Data flow.
data flow.
Mm-hmm.
Okay. So as usual, give the all the required information, and you can see. You can here you can have as option to select the data flow you want to execute. So data flow we have created one, so we can execute one. And if there are any parameters, we can give or nothing. Okay. So what is saying parameters? Okay, just validate. Good. And debug.
So basically, we need to always select data flow and select inside the whatever data flow we created, correct?
Yes.
Okay.
See, data flow you cannot execute automatically. It has to be integrated with the pipeline, and then pipeline part of the pipeline activity, and then execute the pipeline.
Mm-hmm. Mm-hmm.
Right. Now, let's say if you schedule this pipeline, the data flow going to execute it every time whenever the pipeline runs.
Mm-hmm.
Right.
And again, one basic question, sir. I know that whenever we have source and destination or source and sink, we should have two data set always, right? That's the recommendation. We should not use the same data set, correct?
Absolutely.
Okay. Okay. Even we know that the same data can be utilized. There is no issue, but even though it's a recommended always to use two data set.
Right. So don't confuse with input and output. See, you can within input, if you want to create a multiple data sets, then think of parameterizing. But don't confuse with parameterizing using input and output. That's logically doesn't make any sense. So wherever logically it makes sense, those scenarios only think about parameterizing and reusing the code, right? So that's the crux of parameterization.
Okay. Okay.
So it's taking a while. Okay, so we'll see. Okay, so it took around one almost 2 minutes, right? Now let's see the output. Okay, you can visualize the outputs in this way, right? And you can see what are the stages it gone through and how much time it took. All the things you can visualize. Okay, you can see the streams, which stream got executed when on the sync side. Okay, so now you can see how many new updated, dropped, drifted, all the information you can see. Okay, so this is how you will execute the data flows, and you will by creating a pipeline and do that. Okay, so now there are other like conditional split exist. Is anybody from SSAS background, or anybody using SSAS? Sachin, you are using, right? No?
Uh, Partially, not a lot of, yeah, but partially I use.
Yeah. So I would say I will share a very good document which basically gives you how these you can see my screen, right?
Correct, I can see that. Yeah,
Okay. So now if you see, we discussed about join, right? So join is basically join data from two streams. Okay, so similar in SSAS, if you are familiar with SSAS, you have a merge join. Okay, so how it works in SQL Server, you have a inner, left, right join. So these kind of join types, if you are familiar with SQL Server queries and all, so the same way how inner join or left join, right outer join works, you can use the same, achieve the same thing using the join transformation. Conditional split, route data into different streams based on conditions. For example, I have 10, 20, 30 departments, right? So for example, I wanted to create three streams. All the employees belong to department 10 should be one output. All the employees from department 20 should be in another output. And all the outputs from the department 30 should be in another output. Right? So that can happen through conditional split. You can mention those conditions. And basically, it's a same conditional split which is available in SSAS also. Now, if you're SQL Server, it's kind of a select into where clause. You're splitting the data based on the where clause, right? Where department 8 or 10 equal to one output, where department 20 into another output, and where department 30 into another output, right? So, so these other examples, it's easy. It's not so difficult, but yeah. So now we will continue with these other examples in tomorrow's class, and we'll see how. Today we touched upon join, and tomorrow we're going to discuss about conditional split, exist, union, as well as lookup.
sir, do you want to share this PDF file with us?
Definitely, we will share with you. Okay.
Okay, thank you. Thank
Yeah.
you.
So that's how data flows work, and you can create data flows, and you can execute multiple times, and you can associate one data flow with multiple pipelines, and you can execute accordingly. Okay, any questions?
No questions for now.
No questions. Okay, so again we will resume tomorrow to understand more on the data transformations. And once the data transformations, once the mapping data flows are done, and there are a couple of other as part of the syllabus, other things like I wanted to cover about global parameters and some of the real-time scenarios where how to creating the pipeline by creating a master, and then creating the dependencies between master and child, right? So these are the real-time scenarios going to cover early this week or next week. Okay, so with that, I think we are pretty much close to completing Azure Data Factory. And if you still are doing those exercises and all, I would again recommend you do that, because see, your experience is your experience, right? So do that. And if you are facing any challenges, anything, you can come back and we can discuss in the next class. Yeah. So any last questions, we can take it up before we wind up. Yeah, Sunita, you want to ask anything?
No, sir. As of now, no questions. Once I start practicing, I will get doubts and then I will get back to you.
Yeah. Do that. Do. I know you working, and it's very difficult to manage both the things. But when you're committed to something, it's our responsibility to make that, create that balance, and learn, right? So I do the same thing, and I mean, I'm just giving my own kind of a example. So what I do is, basically, I also still learning, and I'm also taking some trainings and all, right? And so how do you balance? I know sometimes yesterday I was working till 12 o'clock, 11 o'clock, 11:30, 12 o'clock. And again morning I have a session from 7. Right? It happens. It's sometimes it happens. And if it's become too much, maybe you can decide to take a leave and prioritize between the your work as well as the learning, and accordingly you can balance both the things.
Yes, sir.
Yeah. But many people come with saying that, I'm not getting time and all. So time is in your hand, right? Is in our hand. You are not going to get more than 24 hours for sure. But how do we manage these 24 hours is what the uh, crux, right? So
Yes, sir.
balance it, and you definitely, um, you have to prioritize both the things, and sometimes the left side and sometimes on the right side, right? So balance it and make a forward. Yeah.
Sure, sir.
Okay. So we'll resume tomorrow. So you want to continue the same time, Sunita, tomorrow?
Yes, sir. It